hazards of radiation were first discovered by analysing the appearance of lung cancer in uranium miners who were working in the Czech Republic back in the 19th and early 20th century. Prior to that, people thought because you can't smell it and because you can't see it or touch it, then it must be harmless. And it was only through these health effects, genetic damage and cancer, that people realised that radiation was harmful to human health.
Western Australia contains 25% of the world's known uranium deposits. The state now faces the prospect of several uranium mines operating, with dozens more projects proposed across the state. This is an industry that will impact each community near a uranium mine, each town and driver on a transportation route, and every mine worker who comes into contact with uranium during its extraction or its refinement. These communities, workers, and the people of Western Australia deserve to know the basic facts about the health impacts of radiation.
Natural radioactive samples emit various types of radiation. The three main types that we encounter are called alpha, beta and gamma rays. The alpha rays are strongly disruptive to the body's cells because they have a lot of momentum and can break the cells apart, but they don't penetrate very deeply because of the strong interaction that they have with the body or any other sort of material. Another type are called beta rays, and these high energy electrons are more penetrating than the alpha particles, but even so they don't penetrate more than a millimetre or two into the body or into the material that's maybe used for shielding. However, they can cause a lot of damage also. The third type are called gamma rays, and the gamma rays are high energy photons or particles of light. A lot of them will pass straight through the body, but they are also deeply penetrating so that they can irradiate the internal organs even from the outside and cause damage, quite severe damage.
The uranium industry is fond of telling the public that its product is not particularly harmful to the human body.
The mining is very safe. The tailings are contained. I mean, radioactivity is natural. It's normal. You know, you're radioactive, I am. People live on the Darling Escarpment. It's radioactive. It's granite. So there is natural background radiation. We shouldn't be afraid of it.
This is the old Lakeway uranium site. It was mined many years ago, or some trial mining here, and this is obviously the residual waste from that trial mining. The radiation counts in this area, we're getting a reading of around about 10.413 microsieverts. It's still just at waist high, over 1.402 microsieverts per hour. Which shows that the whole area, we're getting gamma or beta from the exposed uranium in the area. Clearly we're actually getting point sources much higher, but just generally as we click on, the area is pretty radioactive. We're here in Statham's quarry in the Darling Scarp, and this is a granite quarry, and quite clearly you can see from the reading we're getting at a 0.16, ranging up to about 0.18 microsieverts. So we're really virtually compatible with Perth. It makes a lie to the fact that uranium is no more radioactive than the Darling Scarp. If the industry has been misleading on how radioactive uranium actually is, has it also been misleading on how radioactivity from uranium impacts the human body?
Ionising radiation is damaging to human health in a number of ways, particularly particles that are ingested or inhaled into the human body. And this relates primarily to alpha particles, and in the form of radon or gas or other particulate matter that is inhaled into the lungs or into the digestive tract, it brings these radioactive particles in contact with human cells. Radiation damages the human genome, it damages DNA, and that process is involved in starting the chain of events that leads to cancer and also hereditary mutations.
Disease amongst radiation workers and uranium and mineral sands miners is lost in the general incidence of disease that everyone in society is vulnerable to. These people may have much higher incidence, but the records aren't kept and no follow-up studies are done, and if they later succumb to a fatal cancer, it's probably attributed to their diet or their lifestyle.
The acceptable dose limit for a uranium worker, provided that the worker does not spend more than 2 years in the industry at a time, is comparable to a dose allowable for a terminally ill patient. Potentially thousands of workers and dozens of communities will face the impacts of uranium mining without adequate access to information about the hazards of this activity.